Phylogenetic trees for dummies. This video is a how-to on how to read and create phylogenetic trees and cladograms, brought to you by Sheila Harris and Tanya. These are the levels of classification: domain, kingdom, phylum, class, order, family, genus, and species. The levels of classification are like Russian nesting dolls. The smallest would be the most specific: species. Species are placed into groups belonging to more comprehensive groups. Groups of species are placed into genuses, groups of genuses are placed into families, groups of families are placed into orders, and so on. Here's the classification of the domesticated dog. Dogs belong to the domain Eukarya, the kingdom Animalia, the phylum Chordata, the class Mammalia, the order Carnivora, the family Canidae, the genus Canis, and the species Lupus. Cladograms. A cladogram is a diagram used to show the relationship among organisms. Lizards have amniotic membrane, lungs, and jaws, but they do not have hair. They have a tail, and they don't have bipedalism. So everything below amniotic membrane doesn't have an amniotic membrane. Everything above it has one. Same goes for the jaws, lungs, hair, no tail, and bipedalism. Phylogenetic trees. Phylogenetic trees are branching diagrams showing the inferred evolutionary relationship among various biological species. The data used to comprise phylogenetic trees are homologous structures and DNA and protein sequences. The difference between phylogenetic trees and cladograms are the branch length in phylogenetic trees correspond to time, and the branch length in a cladogram has nothing to do with time, but both show relationships among organisms. In my phylogenetic tree, there are 6 species of aliens: alien Q, V, U, R, S, and T. Alien Q and U are more closely related than Q and S because their last common ancestor was 50 million years ago, and the last common ancestor between alien Q and S was about 100 million years ago. How to make a cladogram. Here are the steps. Determine the similarities among organisms. This will usually be organized in a character chart. Our traits for our character chart are fur, amniotic membrane, lungs, and jaws, and our organisms are bear, lizard, newt, perch, and lamprey. Your second step is to arrange the organisms in a tree diagram showing the simplest evolution. You must use maximum parsimony to do this. Maximum parsimony is a trait is assumed to have evolved once and be present in all descendants. So after you put jaws, everything after jaws has to have jaws. So by going by our character chart, we start with the one without any of the traits, which will be the lamprey. The next one would be the one with only one of the traits, which is the perch. And the next one should be the newt, because it has lungs and jaws, but it doesn't have an amniotic membrane or fur. After the newt should be the lizard, because it has an amniotic membrane, lungs, and jaws, but it doesn't have fur. The last one should be our bear, because it has fur, amniotic membrane, lungs, and jaws. Here are examples of some bad cladograms. The lamprey and the bear are where they are supposed to be, but the newt, the perch, and the lizard are not. The lizard, as we looked at before, has not only jaws, but it has lungs and an amniotic membrane. So it should go here. The newt, we know, does not have an amniotic membrane, but it does have lungs and jaws, so it should go here. The perch, we know, does not have lungs, amniotic membrane, or fur, so it should go here because it has jaws. In this cladogram, there is no use of maximum parsimony. So lungs on this cladogram have evolved twice, going from the salmon to the frog, the first evolution of lungs. Then there's the evolution of fins, and goes back to the perch, which doesn't have lungs. And then the lungs evolve the second time, and you get the snake, and then legs, and then a lizard. Thank you for watching. The creators of this video are Sheila Harris and Tanya. And thanks, Mommy, for lending the iPad.